All right, today we are going to design an irrigation solution. So we have a 25 kV utility feed coming in, and we want to power two 250 horsepower 600 volt motors and a lighting panel for lights, receptacles, and that sort of thing. Let's get started here in EKX. We'll start a new project, call it irrigation uh, project A. We'll use the NEC code, create that. All right, first thing we'll add a utility. And we'll put this at 25 kV. And we'll add a transformer. These are just auto-populating or building by themselves here. We'll use typical impedance of 5.75, XR ratio of 8, delta Y, that all looks good. Make it oil and no taps. This will be a distribution transformer. So 4% impedance. So this looks good. Now we'll have a cable coming into our building, our E-house. It'll be 3 conductor. Number 3, we don't need a neutral, so we'll stick with 3 conductor. I'll leave the sizing for now. Then we'll have a main breaker, a bus. And we'll have 3 loads, so breaker, cable, and our lighting panel, breaker, cable, and our motor. And then we'll do that again, breaker, cable, and our motor. Now let's size some of this stuff. So our load is 200 amp, but we'll change the demand to maybe half. So we're just running, actually it'll be quite a bit lower. There's just lights and receptacles, so let's bring it down to 0.2. That looks good. All these cables will be 3 conductor, tech. And run a load flow. Actually, let's move our motors to the right horsepower here, 250. And you can see the yellow or orange here is the auto sizing feature. So we changed the motor to 250 horsepower. It sized our cable, our breaker, and our transformer up here. Go to here, change this to 250 as well. And we got our transformer changing. A bit of an odd size here. Round up to 1,000. This main breaker will have to be a bit bigger, I believe. Let's run a load flow. Separate this out a little bit. Everything sticks to the grid here, so we don't have to worry too much about that. About trying to make things look nice. They tend to just align. So I have a 1,000 kVA transformer, 65% loaded, just over 600 amps on the secondary. 3 runs of 350, that looks okay. If I wanted to, this auto size for us, but if I wanted to use 500 as a more standard size, we can lock that in so it doesn't get readjusted. And then you see the lock there. Now we're only 50% loaded. Just wonder if we can move down to 2 runs. That might be a little tight. 80% loaded. Okay. That's not bad. I don't mind that. To bump up this breaker. The next size up here would be 800, it looks like. Rerun that. Now this is a low voltage breaker, so it's 80% derated. So that's why we're seeing 96.5% loaded here. It's pretty tight. Okay, what else do we have here? So our motors here, size to 350, which is 93%. 350 is 310 amps. They're going to be further than 33 meters away, so move it to 30. This one too. So now we have a 0.5 voltage drop, not too bad. We're seeing 0.96 here, 0.97. That's right around the 3% mark, which is getting pretty tight. So what we'll want to do there, let's go in our project settings, go to sizing, cable, let's find cable. Make our default cable Tech 90. We want copper, and that looks okay. Okay, this all looks okay. See, as we have a transformer sizing margin, 20%, that looks okay. I'm going to bump these up to 500 just to give us a bit more breathing room. That looks better. We're back in the green, and we'll copy that data and we'll move it here. That one's back in the green as well. You can see the majority of our voltage drop is coming from the transformer itself. 65% loaded, so 2.6 drop there. The lighting panel only taking about 40 amps because we've derated it. Not derated it, but have a lower demand. This is not bad. This is, I don't want to review this again, but something just to whip up. Gives you a good idea of what kind of distribution equipment you would need.